Right. Give me a second here. So I guess let's open IP and share your screen. Yeah. Okay. Yeah. So this is interesting that it's in meters. Um, as well. Okay, so we have very little core in this one, right? It's like what, 30 to 40 feet of core, that's it. Yeah, we want to find one that's got quite a bit of core in it. So let's look at that that I sent you that's in that PowerPoint, right? That we looked at before. Uh, there was a screenshot from that Core Lab PowerPoint with whole core sections like and well numbers. Remember that thing? Okay, well this might be a good one. This is where is this well at though? That's the question. University 45601. Um, give me 1 second. Let me open. I got a hold on, I got another database open that I need to take a screenshot of for Corey. I wanted to look at the dean of K. Hold on a second, I'll show you how to do it. Let me just get this thing off the Corey. Oh, it's saying this. He is. I don't even think I had this one. IP for no, it's not the one. Uno momento, per favore. Okay. University, I think that's one of those ones down there on the Ozona Arch, which in case we do not care about it. Yeah, it is. We don't care about that. Um, let's look at what else have you got in your folder there? Can you show me the well names of the WellCat files that you've got and I'll cross-reference? Okay, so yeah, just leave that open for a second. Let me look at it and I'm gonna check the map here and see if we can find something. So a Newman monitor, what that's 47 kilobytes. That looks like that might have some stuff in it. Let's look at that. Okay, so this one's got 70, at least 200 feet, 300 feet. All right, so let's do this one. So how do you load this, you ask, right? There's a couple ways. So let's go to IP, find that well, the Newman monitor. I think it's well number 41. Do you know how to sort those lists? No, no. Go into where the list is, and then you can do that too. But go right click like where the well names are. And then go down to where it says display options. Sort by database number. There you go. So let's go to the import export menu on the top. Yeah. Yeah. And then go all the way down to where it says interval spreadsheet loader. Yeah. So this is the way that you get pretty much any sort of data into IP that is not a last file, right? And what we do is we need to paste it in there, and we need to do a couple of things. I'll show you how to do that. So go to your Excel file. And then select all the data from, like, get rid of that thickness column, just delete that thing or whatever. We don't need that. We'll just delete the whole column so that it's just out of there. C is gone. Get rid of C. No, you don't want to delete that one. Put that one back. Control Z. Delete C. C is in. Yeah, delete that thing. There we go. Now select the data from columns A through D or whatever, I guess. And then Control C. Go to IP. And then put your mouse in where it says top depth over there on that first little box. Right next to the well name. Where the white empty box is. Yeah, click in there and then hit the paste button. It's right there on the bottom. You have to actually push the button that says paste. No, there's a button. There's a button in there. You see, go down to the, go down. Down, paste. You see paste? It's down there next to like clear. Yeah, right there, paste. Okay. Now, we need to delete that first line because we don't want that in there, right? So you can, there's a button there that says clear row. Just hit that clear row, but select the first row, and hit clear row. Yeah. No, not this, just the first one. Yeah. Yeah, you have to click in where the data is. They click where it says top foot or whatever. No. You have to click in where the data is, like where it says top depth, it says top underscore FT. Click in there to select it. Click again so that it's active, and then hit clear row. There you go. All right, so now we need to specify the curve names and all this stuff, right? So go up to where it says curve name. Up where curve 1 is. Curve 1 on the very top. Yep. So type in there. You type in there because the curve doesn't exist yet. Type in there like lith 1. And then for the second one, lith 2. So that's what we'll call these things, and we'll just assume that one of them is the codes for the different things, and the other one is the lithology description. So now we have to change the data types for each one of these. We have to change it from a numeric to a text because these are not numeric, right? Now, the second thing that we have to do is we need, if you look at the spacing on these, right, the descriptions are done like every 0.1 or 0.2 feet or something. It's like, it's hard to tell, 0.3 feet. So we need to create a new curve set to put this data in. So there's a button on the bottom that says edit sets. So click on that. It's like in the upper right kind of, or where all the buttons are. It's in the upper right down there. It says edit sets. It's right next to where the curve set button is. You see? No. Go all the way down to the bottom. go out. And then, now we're gonna just type at the first blank box, yeah. Just type in there, type in like, lith, Lith. And then do the same thing for the second box. Okay, now I want you to hit the update sets button. Okay, now hit the edit button for that set on the far right. There's an edit button. You have to select the lith set, so go up to it. It reordered things alphabetically, so you have to scroll up. Yeah, go to lith. Go all the way to the top. Yeah, there it is, lith number 11. Go to the far right, hit the edit button for that. Okay, now I want you to change the step from 0.5 to 0.1. Go third box, 0.1, and hit the run button. And say yes, yes, we don't care. Well, okay, now close. Now select, say yes. Okay, now hit the load button in the lower left. Okay, so now if you expand the well in the database tree on the left of the screen, and you can double click on, leave that open, yeah, don't close that. Go over to Newman Monitor 1, double click on Newman Monitor, way on the left in the tree view. Tree view, way on the left, not in this screen, in the database browser, left-hand side of the screen. Keep going to the left, keep going left, 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 keep going, keep going, keep going. There you go, that thing. Expand that Newman Monitor well. Expand the well, you have to double click on the well name in the tree. Expand it, go to the curve sets, expand the curve sets. What are you doing? No. Expand the well. Expand this well. Now open the lith curve set that's got the curves in it. Now double click on one of the curves. Now scroll down to where the core is, which is like 7,000 feet or whatever. Okay, so we verified now that we have the core description in there, right, loaded. Now, this data is not useful to us, for plotting because it's text, right? What we can do is we can do, classification or whatever, if we convert these things to numbers, right? If we want. No. Well, that's fine, and that's good to have that. We need it anyway, so that we know what these are, right? But we're going to have to make a master table where we assign each one of these descriptions an integer, right? So we need to make a unique list of all of them, which we've got. I believe the WellCat files themselves, if you open them up with the reader that you installed, the free one, it should show a table at the bottom. If it doesn't, the thing I sent you that Sebastian created, the PowerPoint. Hold on a second. Let me open that. Let me find that. That thing has a table in it also. Yeah, the conversion PowerPoint that he made, where it's showing how you convert to the 8 bases. Where is that thing? It is somewhere. Somewhere. I have no idea where it is, but I'm looking. Browse. I think it's under I always can never find this thing. I always look for it, and I can never find it. I sent it to you at one point. Uh, this is bad organization on my part. Riesling for, this is all the ML work I did, but not, it doesn't have that table. Yeah, well, they're, keep in mind, right, that the two of them, they're not even a year in, right? Let's see, where the hell did I put this Petrotates forms? Secondo, is that the one? There's a whole PowerPoint that he made, and I have no idea where it is. I had to do this last time too. I thought I moved it to a folder so I could find it. Um, Bar Basin, that's where I put it. That's where I fucking put it. There it is. Why do I keep forgetting that's where I put it? So this, I'm gonna cut and paste these because it's just easier to do that. We're having trouble, is what Teams tells me. There's no fucking chat. It won't let me. All right, I'll just put it in the other chat. So, yeah, Teams is busted as usual. Piece of shit. All right. So those are the definitive. If you look at your Microsoft Teams, ignore the Delaware Basin one because we don't care about that, which is on the far right. But the middle one, right? These are the classifications. So the text that you've got, like, I don't even know what's in those files, right? But it says like AGIS or something, right? That's argillaceous siltstone. SI is siltstone, right? WCSI is weakly calcareous siltstone. Like, ALI is argillaceous limestone, SALI, or SIAG, whatever, that's silty argillaceous limestone. So there's 30 of these things, right? And we can map these to integers and then load the integers the exact same way that you just loaded this data, right? But I don't want to do that yet because what we need to do is work with the client to figure out how they want to map all 30 of these to like 6. Like that document that Sebastian had, which I think I now have open, right, is yeah, well, he's got, this is what he did, right? He mapped all these things out and then said, like, here's how you do it. So, follow these steps, export the data from the WellCAD files, right? And then, you got 1, 2, 3, 4, right? And then he's using these things to do that. And then he says for the next steps, you got 2 options, option A and option B, depending on how you want to spin it. Up to you. Okay, right, so there you go, and then at the end. We get these different lithofaces. Now, my opinion is for a first pass, we should probably do what Sebastian, what his document says, right? So if you follow these logic bits, you could write a Python script or something, right, to process these files and condense all of this stuff to numbers 1 through 8, right? And that's what Tim had written one of these already, and he's gone now. So I never got a chance to get that from him before he left. At least I think actually today is his last day. Let me ask, hey Tim, I get that Python script from you that you used to convert Sebastian's core bases before you saddle your Shetland. All right, so yeah, we'll get that from him as a starting point. But what we'll do is so like silty shale, weakly calcareous silty shale, silicious silty shale, all of that is silicious mudstone. So that gets turned into a 1. Packstone and grainstone is a 4. Floatstone and rootstone is a 5. Lime, wacky stone, or dolomite texture. So that's the difference too, is we have textures and we have lithologies that are coming from these things, right? So you loaded 2. So we've also got the if you open up your lit 1 curve in IP, double click on that. Yeah. And then let's look in there. So that's the texture, not the lithology, right? So these things and like yeah. Well, I don't know. It should be like packed stone, float stone, root stone, grain stone. These look like these are still lithologies. These are not textures. So we have to get the texture data out of the WellCat file yet. It might be hidden in columns E or F, or we may have missed it. But you need to get the texture as well. So here, let me find and we may need to do some more work on that extraction script, right? That it's only getting the lithology, it's not getting the texture, because we're using the texture in the script as well. Yeah, hold on, let me find an example here, open. So the texture is a Dunham classification, so it's going to be either bound stone, root stone, float stone, grain stone, packed stone, wax stone, or mud stone. That's what you're going to get out of that. And I'm looking for. You have texture in one file? Yeah, if there's any files that are failing, we need to look into that because they should all have texture. Yeah, perfect. So now that's what normally we get out of these things, right? Where you've got that texture will go. So like the ASI is the argillaceous siltstone, and then where's the texture at? There is no texture. No. Yeah, okay, we got it. Packstone, dolomite. Yeah, those are the ones that. Well, I don't even know if there's dolomite. See that? Something's wrong, right? You should only have bound stone, root stone, float stone, grain stone, pack stone, wax stone, mud stone. That's it. That's it for texture. Yeah, so we'll have to try to figure that out one way or the other, what went wrong. And like I say, we need to spot check some of these things. And I'm still waiting for them to install the full version on my Diamondback computer. Once I get that, I'll be able to do some manual extractions, right? And then we'll use that to spot check. And the other thing we could do is we can use it to reverse engineer the Python script. So you put it into Claude, right? And you tell it, here's a WellCAD file. Here's the extracted bit of the WellCAD file. Here's the answer. Go into the file and figure out how to extract it, right? And Claude will figure that out. And then once it figures it out, it'll update the Python script, and then we can run it on and check more wells, right? But well, yeah, well, part of the problem is we don't have the answer yet to give it, right? That's what we need the WellCAD software for, to do the extraction. We don't have it installed yet. So, you know, we just have the free version to read the files. We can't export. So, but that's going to be the general workflow here, is that we load this stuff up like this. You know, once we get it out properly, we'll have to load the integers as well once we convert everything and we get all that, you know. And then when we have it, then we need to load the logs. So like, for example, let's just play that game really quickly while we're here. Wait, you know, we can use that to bide time. So you've got, which well did we pick again? The Newman monitor. Do you have logs extracted for that well? Yeah, just like a gamma ray log somewhere or whatever. Boy, I fucking hate life. You know, like everything's got to be so damn grab, right? All I want to do is order food. You know, like, why does it have to pop up 500 ads that I have to click through every single time? You know, like, just let me order my food. You don't need to give me advertisements. I don't need advertisements. I know what I want to order already. Yeah, I was laughing. I got my haircut tonight. I was talking to my barber, and he had the radio on, and they had all these ads, you know, Misa Machik Premium. I said, what? I said, is that a Thai word? Premium. I said, is that Hasa Thai or what? You know, it's not English. It's not Thai. It's somewhere in between. Misa Machik Premium. All right, so let's go down where the core is. Yeah, yeah. Scroll down to where the core is, like 7,000 feet or whatever. Looks like the gamma ray values are just flat lined up there. Yeah, there you go. So now let's select the depths, right? Like let's get like a block out of there from like wherever that data is, like 7,200 to 70 whatever. Or I can't remember where the data is, but yeah, just select the gamma ray. You probably delete column B, so you don't need it. I don't even know what that is. It's all zeros anyway, so. Yeah, just delete that thing. So yeah, select a nice block from like 7,000 to something where you got all those good values. And then we'll just load it the exact same way. We'll put it into that spreadsheet loader, put the depth and the value, and it'll be easy to do it this way. Yeah, you just want the first two columns. But you only want it from like 7,200. You don't want the whole thing, yeah. So you're just gonna have to like drag a box, right? I normally drag a box or whatever, and then I do like whatever it is, shift and page down, or I don't know what the. Yeah, you need to learn Excel for engineering. Like, this is a huge part of your life. It will be, and you know, like all this. There's like, Excel is one of the most complicated computer programs in existence. And if you look at all the shortcuts on the keyboard and stuff, there's like literally tens of thousands of them programmed in here or something. You know, like, you wouldn't even think it's possible. But there are, like, there's so many tricks in Excel that you could use it for your whole lifetime, and every day you'll find something new, you know? Yeah, let's go to IP now. And then go to that import loader that you got. It's already open, right? It should be open on your screen there, spreadsheet loader. Yeah. Now just hit the clear all button on the bottom. Yep. Yeah. And then do the same thing. Click on the now the one thing that we're gonna have to say yes. Now the one thing we're gonna have to do before we paste is, because we don't have a bottom depth, we need to, there's a button there that says no bottom depth. There's a checkbox. You see it down there, like the middle bottom of the screen. It says no bottom depths. Check that one. And now put your mouse in the first white box there in row 1. That's got no, yeah, the next one. That's the well. You don't need to select it. Oh, yeah, you do, I guess. Yeah, put Newman monitor in there. And then, yeah, first white box, click in there. And now hit paste. Hit paste. Give it a second because it's slow as shit. Well, it's not the computer that's slow, it's IP that's slow, right? Also. It's just really slow when you paste a lot of data in it. You have to give it a second, or 3 or 4 or 10. Yeah, curve name, just type in GR for gamma ray. And that's gonna be numeric, yeah, and then just go ahead, it's already in the right set and everything, so just hit the load button. Yeah. And then give it a second. Okay, so now go to your log plot. And now drag that gamma ray curve into your first track with the other gamma ray. But you put it in the tops track, put it in the gamma ray track. Yeah. Close out of that. Now scroll down to like 7,000 feet or whatever. Okay, so now we need to rescale that curve. Zoom out as well. We're at 500. Zoom out to like 5,000 or whatever. Yeah. And then change the scale for that second curve to 200. And make it like black or something, a different color. Right. So what we're trying to do here is see how far off depth it is, if it matches at all and all that stuff, and then we'll understand how to do the depth shift. So there are some significant differences here. You know, I think the pattern matching of it will probably look fairly good. I don't see that there's any massive breaks, right? Like it's fairly consistent. It's just that sometimes this gamma ray that you're looking at, right, it's been measured core or something. So it's different. It's like where you got washouts up there, it's much higher because the response to the logging tool is what's the word I'm looking for? It's attenuated because the wellbore is too big, you know. So this is how you depth shift. Okay, go to the I think it's the edit menu. Interact, yeah, hit no. Hit no, we don't want to use the wizard because the wizard's kind of a piece of shit. So No, no, no. We're gonna just type it in. So for the first box where it says input curve, put in your final gamma ray curve. You can't drag and drop. You're gonna have to type it or expand the box. If you hit the little expand and just type in the G key. And then find GR. Well, you got T in there. Hit G. Gog eye. G. There you go. Find gamma ray from the final set. There it is. You scroll back up. You want right by it. Want by it. Want by it. Want by it. Keep going up. Nope. 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 Keep going up. That's KTH. Final gamma ray. GR. Yeah. So and okay, now click on the second row. And go to the first. Don't leave that alone. Go to the first box. Leave that alone. Unclick out of there. Go to the second box below that. First row, second row, first box. Yeah. Now put second row, first box. Put your GR from your lith set. G, just type G. You can't do more than one letter, just one letter. G, and then it's your G's. Okay. Now, the way, and then click off of it into the third row. You have to click off of it for it to update. Okay, so stop. No, we didn't want to do that. We wanted to leave that. So click on your second row, first box, click off of it. Leave that DS in there. We need to have that in there in the output curve, okay? So the way that this thing works is that you have it's a grid setup of what you're doing. The first box is the curve that we're putting in as the reference input curve. The second box is what it's going to write out when it does the depth shifts. For the first one, we don't need an output curve because we're not depth shifting the first curve. It's only going to be used as a reference curve. Okay. The check boxes, there's 3 check boxes on the right. Those we need to set up. So for the first row, check display and reference only. For the second and the third boxes. For the second curve, check shift and display only. It's not a reference curve. That's the one we're shifting, but we want to display it. We want to display all the curves. Okay. Now, the last thing that we have to do is we have to name the depth shift curve that we're creating. So it's got it. Yeah, it's there. Put the curve in the lith set because, yeah, we have to. Okay, get out of there. Get out of there. Get out of there. Just where it says output set on the top, you see there's like a button with blue text in it. Output set right above that. Click that. And then select lith. Yeah. Okay. And then click in the first line, I guess, and see if it didn't update for some reason. I don't know why. Yeah, you have to click in the now hit the output button while that's selected. Yeah. Now I'll do lith. Yeah. Okay, doesn't we'll just type it in there. Just type in lith colon DO or something for depth offset. DO, yeah. GRDO, whatever. It doesn't make a difference what it's called as long as it's not overwriting one of your other curves. So we have to put a DO at the end of the curve name. Yeah. All right, now hit the start button. Delete that 1 out of that third line. There you go. Now you go. Again, this software is old, right? So it's not. Now leave that window open. Do not close that window. You close that window, you kill everything. So leave that little window open. Yeah. Now adjust this. Well, just scroll down to where the data starts or whatever. Okay, so make the window narrower because when you expand it really wide like this, it's difficult to see shifts and stuff. You kind of have to just minimize those things, get them out of the way. Yeah, make it a bit, okay, now change the scale from like 200 or whatever to 600 or something. You could put that to 200, 300, whatever, that's fine. Okay, hit okay. You don't have to enter data for redundancy. It picks up whatever's in the first row. So change the scale from 200 to 600 or something like that. You have to click on the close out of that. And there's a drop down box, yeah. Okay, so now scroll down to where the core kind of starts, wherever that is. I don't even know where it is. And you can see now what's going on here, right? Like this gets very interpretive. So you have to find a good spot to start from. I think you're way too deep. I think you need to go way back up to like 7,000 feet. Yeah, there you go. And then like don't start there because we don't know where we're at. So we like scroll down a bit and see if you can find a spot where it's very strong correlation, that you can anchor things on. Keep going. This is not it. Still looks like shit. Keep going. Keep going. It's noisy. That's a good spot there, I think. So you can see if you look at the gamma ray, right? You may want to decrease, go up to the top and click on the curves again. Yep. In this case, we're going to want to change the scale for the final gamma ray curve to like 150 or something. And change the bottom one to 300. And so what we're trying to do is amplify one because the other one's strong, Yeah. Yeah. And we may have to mess around with these until we get it right. This is all just about visualizing it, right? But now you can start to shift. And you may want to zoom out even a little bit more before you start getting in there to make sure, like 1,000. That's probably too much. 1,000. And then go change the scales again. So it's like, instead of 150, it's 225 or something like that. Yeah, there we go. That's starting to look better. So yeah, you got to kind of figure out what's going on. So when you make a shift, we have to stretch and squeeze the data, right? Until we get it to work. And then it's just going to be the matter of doing this. And it's going to get really tricky with core because core is like, it's the rock, right? It's a fixed chunk of rock. It doesn't stretch or squeeze, but the logs do. So what we're doing is like reversing the core to the logs, essentially, right? We're stretching and squeezing the core to match the logs instead of going from the logs to the core. That's just the way that we do it. It's kind of backwards, right? But so you're going to have to figure this out, and it gets tricky. And this is part of what you do is you have to find good anchor points where you have a really strong signature, like there, where you're confident of that. And that's where you set your anchor point. And if there's something in between that you're not confident about, you delete these anchor points. You don't send too many of them, And if I were doing this, I would be really, I guess you can take passes at it, right? Like if I do it normally, you can start with a pass at 1,000, just kind of go through and just don't try to get too complicated. Just look for really gross, like very obvious trends and lock them in place. And then come in at like 500 and look for more details, right? And then come back in at 250 or something and clean up. Yeah, because you don't want to go small to big because then you're lost, right? You don't know where you're at. And the other thing you may want to do to help you with this is you can run a filter over that gamma ray curve from the core to smooth it out. And if you want to do that, you can do it. I think it's the edit menu as well. If you go up to the edit menu, there's a per filter, right? Yeah, you run that. And then you can put your curve in there, rename it or whatever as an output curve, some different name like GR or F, I don't know. Yeah, you have to find that core GR curve. Yeah, you have to learn how to use IP, that's the reality of it. You got what you got. And then there's an option that says create new overwrite curve. Do that. And then it's got GR1 as your filtered curve. Change your filter height to like it's doing it in feet samples. So change it to like 2 feet. And then run it. And then so now you've got a new curve. Now the problem is we need to rerun the depth shift module all over from scratch, right? So you have to close that little window I told you never to close. Hit cancel on it to discard the shifts, and then close that window. That's garbage now. And then go back to the edit depth shift. No. And then instead of the final GR, we're going to put final GR1. Nope, yeah, that one. Or no, I'm sorry. Yeah, leave that one alone. Put the GR1 for the lift curve. There we go. Now just leave all the rest of that the same and hit start. Say no. Nope, we don't want to use the existing shifts. So now we've got a filtered curve in there. You can just scroll down and see what it looks like. It's a little bit less noise in it, right? It may help you with your shifts. Not as noisy. Yeah, like I say, do the bulk shifts first. Like some of these things may be off by quite a bit. And you may even want to zoom out even more to like 4,000 or something. Or whatever, 2,500. Yeah, just to kind of see like, where am I at here? Is this even, am I off by 100 feet? I don't even know, type of thing. This happens a lot when you get into these sort of projects, and things could be off depth by a significant amount. Stop right there. Like this is good. Scroll up a little bit. Yeah, there you go. Go back up, scroll up there. That thing at 10,000 feet, right? That is a good signature for, you can zoom in on that and you can match it. And then that'll set you, probably not that much. You can zoom out a little bit more, but you'll figure this out, right? Like it should, like I would move that down so that spike where your mouse is, yeah, move that, keep going, go down, go down, go down, go down. Keep going, 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 keep going. Stop. You see what I'm saying? That little spike there, like, does that make sense? Okay, that's you're just testing this, right? Did I go too far? Does it make sense now? And you're like, well, you know what? It doesn't look right. Back it up a little bit. You could just, you back it up. Yeah, back it up so that, well, you want to put, you may want it there. You may want to put it so that that high gamma ray on the pink curve is matching the high gamma ray on the green curve too. Like back it up some more. There you go. Right. Does that look good? That looks better, right? But then you're like, well, okay, what's happening in between? So I mean, there's not core throughout this whole interval either. So this, like I say, there's lots of problems with this shit. Like, where did this core curve come from? Where this gamma ray curve come from? So yeah, I've seen this often with Core Lab data where the data is just shit, and it's confusing and fucked up, and none of this makes any sense unless we align it properly to the logs. Because when we do the machine learning, it's got to be on depth, right? So just for now, play with the extraction thing. We need to get data. I know we can't do anything until we get the software installed. And in the meantime, just play around with this, right? Get comfortable using IP, loading data, depth shifting, using the controls and the software and stuff, because you're going to have to do this once we get the data in. But at this point, we're like in a stall mode, right? We're stuck until we get that software. So perfect time to learn how to use IP's depth shifting module and just play with this, like these sample data sets where you're gonna, this is not easy. So you're gonna have to, like, train yourself. How do I match this high resolution data to the log data? Like, you as an interpreter, you can shift this a million different fucking ways, right? You can just pattern match the fuck out of it. You can stretch and squeeze shit all over the place. But the problem is, does it make any sense? Like, if you look at that little window I told you never to close, it shows you the shift magnitudes that you made. So like, if you're making a whole bunch of shifts and they're all about the same, like 50 foot, that tells you that there's consistency in what you're doing. But like, if you start really compressing the shit out of the data, shifting it all over, and you got like 5 here, 100 there, chances are what you're doing is wrong, because there's no way that the shift magnitude changes from one part of the well to the other, from 100 feet here to 5 foot, right? They should be consistent numbers. Yeah, like 47 to 50 is fine. That makes sense. I would never argue with you on that. But if you had like 50 and then 3, like everywhere, like, that's telling me that something's fucked up. Like, it shouldn't be like that. Because normally the way that this works, right, is that there's usually a bulk offset that could be like 20 or 30 or 100 feet or whatever, that they just got fucked up because they used the wrong datum or something or whatever. And then you've got the actual little stretch and pulls that are happening, which should be like 2 or 3 or 4 feet, 5 feet maybe, right? They should never be more than that. So if you've got a baseline like 50 and it's kind of 54, 47, those are good numbers. But if you're going from 50 to 150 to 300 to 2, something's messed up bad, right? You didn't do a good job with your shifting. So just play, right? Play around with it, learn to use it, and use this time so that when we get the actual data in, you can process it and blow through it quicker, And remember, while you're doing all of this, I told you a long time ago, right? This is the process that I would love to be able to automate. So how do you automate this with code, right? How do you do that? It's a difficult problem. Abstract 4. Which one? Which one? It's the Jakarta one or the other one? Yeah, there was a couple of them, I think. I don't remember myself, right? I submitted an abstract to the Jakarta thing. That's easy because we can get you in there anytime. We can also, try to get you in at the SPE Bangkok as well. But well, they do monthly talks, right? Then there's also, what the hell was it now? So there's the AAPG conference in Kuala Lumpur. Is that the one that you're talking about? What's the deadline for that one? Hold on, let me double check that. Yeah, I'm just looking here. So the ICE Jakarta, they extended that abstract deadline. I think they extended it until the end of the month or something. Or next week, or I don't know. And that's ICE. Yeah, and then the AAPG KL one, that's tomorrow, April 30th. APGCE 2026 Kuala Lumpur. That's the one, the deadline's the 30th of April. So yeah, if you want to submit to that one, we should probably coordinate on that as well, because I wouldn't mind submitting an abstract. Let's see. Yeah, it's this thing here. I'll send you that, right? That's what we're talking about. Yeah, I couldn't think of anything that I had that would, I don't know, where would we put it is the question. You put it in, advances in formation evaluation or integrated reservoir modeling, I think are the two that. Because there's no specific like petrophysics or AI thing. There's a reservoir characterization and facies modeling. So that might be a good one. You know, if we can come up with some sort of paper around the facies stuff, right? But it would have to be, it would have to be on the approach that we took on the machine learning side to match it, which we don't have yet because we, you know, and then the other problem is the data, like what can you show, what can you not show, you know, with a client. Or we don't, you know, a lot of times when we do these things, we can just go find public data. But for this, we're not going to be able to, right? It's other than what I showed you from that one website with the BEG. So think about the that web page I sent you. Figure out which topic you would fit into, and let's talk about that before the deadline is up, which is tomorrow, I guess. So, all right, I gotta go. I got another meeting, and I gotta go get my food too. So we'll catch up with you later. Play around depth shifting. Become a depth shifting wizard. All right, bye bye.